Hi everyone, this is the video for 6.1. In this lesson we're going to talk about inverse functions. So you learned first about inverse functions back in algebra. So remember when you're finding the inverse of a function, we switch our x and y and solve for x. So if we had something like this and we wanted to find the inverse, we would switch the x and y and then solve the equation for y. I think I just said x, but we solve for y. So to get y by itself, we would subtract 1. So x minus 1 is the inverse of y. So if you remember what this means on the graph, they are reflections of each other. Okay, so sorry, I was just checking to make sure I did that right. Okay, so inverse functions is when we switch x and y and solve for the opposite value. So it's a reflection over the line y equals x. Okay, so if we take a look at what our normal trig graph looks like, so before we get all that complicated stuff, our normal trig graph for sine looks like that. So if we're switching the x and y and finding the inverse, remember, it reflects over y equals x, so it would end up looking like this. All the y values now become our x values. So instead of the x being your radians, or in this case this picture has degrees, your y-axis is now it. Okay, so when we have our graph, a normal sine graph, this is a function because you can do the vertical line test and none of the values repeat. But once we do the inverse, it's not a function anymore. So that causes some complications with where our answers can lie. Okay, so we want our answers actually to be just in the shaded part because that makes it a function. So what we're saying is if we cut off those pieces of the graph and we just look at just that part of the inverse that's in the middle here, this is still a function. So when we talk about our inverse functions for our trig functions, they're going to be restricted because we still want them to be a function. Okay, so we're going to talk about the pieces that we have, like where it gets cut off in a second. I have a picture too of both graphs on the same thing. So this is the graph for sine. So here's normal sine. Okay, and then here is the inverse of sine. So it's just that value that's in the middle is where we would look at for the inverse. Okay, and this is the line of reflection. So we're restricting the range of our inverse function to make it where we still have the values that where it would be a function. And this is the graph of cosine and its inverse. The tangent one looks like ridiculous. That's what it looks like. So here's our normal tangent, and here's the inverse of it. Okay, so let's look at your chart on the front. Okay, so we're going to talk about what our domain would be for our new function and what the range would be. So normally our range of a normal sine function is from -1 to 1. So if I'm switching my x and y, that means that my domain for normal sine would be -1 to 1 because we switched it. So we're looking at what our domain is here. So here's -1 and here's 1. Okay, so that's where that comes from. Again, we're switching it. Normally it's -1 to 1 for the amplitude, but now since we flipped it, it's now our domain. So that means that our range is going to be with our pi's, which normally is our x-axis, it's now our y-axis, but we're cutting off those extra pieces at the top and the bottom just to have this part in the middle. I don't know if you guys can see the numbers there, but it's from -90 to 90. That's the part that we're keeping. So that's where our interval is for our range. So our range is actually going to be from -pi/2 to pi/2. So I know that might equate to where you would draw your pictures, and it might not. 0 to 90 is first quadrant, but 0 to -pi/2 would be fourth quadrant. So our quadrants where our range is in quadrant 1 and quadrant 4. And that's going to be important because that's where we'll draw our pictures. And if you notice in quadrant 1, sign's positive, in quadrant 2, quadrant 4, sign is negative. So for all of our restricted quadrants that we're going to have, it's always going to be where 1 is positive and 1 is negative. Okay? So our domain for cosine is the same, because they would, sine and cosine have the same normal range, so now their domain is the same. But the restricted quadrants is different for cosine because the graph looks different. So if we think about what we talked about here, in quadrant 4, sine's negative. In quadrant 1, it's positive. If we made the same interval for cosine, we would have two quadrants that are both positive, but we need a negative one. So that's why cosine goes from 0 to pi, because in quadrant 1, it's going to have its positive value. In quadrant 2, it'll have its negative. Okay, so that's one way to help you remember these, because they need a positive quadrant and a negative quadrant. So since sine's positive in 2, it has to be 1 and 4. And since cosine's positive in 4, it's 1 and 2. Okay, so I'm going to let you copy down the rest of them, and then we'll talk about what we're doing with all of this. Okay, so go ahead and pause and copy all that down. Okay, so like I said, the important part of this is knowing where the quadrants are. You don't necessarily have to know it like this, but you have to know that what quadrant it lands in, because that changes your answers. Okay, so let's take a look at our examples on the inside. So we're finding the value of the variable. So for this one, for these, are we finding angles or are we finding side ratios? Good. We're finding angles. And one way I know that without doing anything is that they gave us 1/2. That's our side ratio. So that means that y is going to be our angle. So they wrote it as y equals arc sine. And arc sine is another way to represent inverse. So they might write it like y equals sine to -1 for the inverse, or they might write it as arc sine. And it's really the same thing. Okay, and remember, like when you're solving for theta, this is what you would do. You would take the inverse of both sides, but now we're going backwards. Okay, so what I'm going to do is I'm going to write it. I'm going to take the sine of both sides. So sine and arc sine are going to cancel out. So we have sine of y equals 1/2. So now we can see that this is sine of our angle equals 1/2. So sine is positive only in quadrant 1 now, since we're restricting our quadrants. And then across from 1 is 30 degrees. So we would have that y equals 30 degrees. So that's where the restricted quadrant comes. Since our equation where we're solving started with an inverse, that means we have restricted quadrants. So we're not going to have two answers now, we're just going to have one. Okay? And that is important because that will be where you draw your picture. Okay, so let's take a look at number 4. So if we move the invert or the cosine to the other side, take cosine of both sides, we'd have cosine of y equals √3/2. So cosine is positive. So what quadrant is restricted cosine in when it's positive? Good, we're in quadrant 1 when cosine's positive. So we know that our y value is going to be 30 degrees. Okay, good. So let's go back to number 3. So do the same thing. Get sine on the other side so we can see what our equation is. So if we move sine to the other side, we'd have sine of y equals -2. So what quadrant is sine negative in? Good, that would be quadrant 4. But think about it before, well, I mean, you can make your triangle, but think about it. If sine is opposite over hypotenuse, we'd have -2/1. But the hypotenuse has to be the long side. So can we have this? Good. There'd be no solution, right? Because you can't have the hypotenuse bigger. Remember, our restricted domain says that we can only be between -1 and 1. But here we have that it equals -2. So we can never have this bigger than -1 or smaller than -1. So that's why there would be no solution. Okay, so why don't you guys try the rest of those examples on this page 1 through 10, and then we will go over the answers when you come back. Number 10, you'd have to use your calculator for that one. Okay, so go ahead and pause, and when you come back, we'll talk about the answers. Okay, so for number 2, if we move sign over, we get that it equals -1, and so that's only true on the negative y-axis. So we got -90 there. Which other ones? Number 5, when does cosine equal √2? Well, that's bigger than 1, so there's no solution for that one either. Cosine equals 1 at 0 degrees. That would be on the x-axis. Tangent equals 145 degrees. Remember when we have our reciprocal function, so we got secant equals 2, and then I flipped it over to make it cosine. So cosine equals 1/2, and then you can draw the picture for that. For this one, we know it's going to end up in quadrant 2 because that's where cosine is negative. And remember about like unrationalizing the denominator, we'd have -1 √2. So that's where we got our reference angle of 45 to get 135. So similar to number 8, number 10, we move the cotangent over and then we flip it, and then you would have to take the inverse again. Okay, so the way you would type that in is tangent inverse of 1 divided by, or it was negative, tangent inverse of -1 divided by 0.3541. Okay. Okay, good job. So let's look at the more complicated problems. A lot of the 1 through 10 was doing what we did at the beginning of the year, or the beginning of the trig, but now it's just in those restricted quadrants. Okay, so for the first example on the next page, it's kind of the same deal, except they give us 2 functions. So they're saying we have tangent inverse of 3/2, and then we want the sine of that angle that makes tangent inverse equal 3/2. So what I'm going to do is I'm going to say that this is theta, that inside part, and then I'm going to forget about the sine for a second. So if I take the tangent of both sides, I'd have that tangent equals 3/2. So if we look at just this part, that's what we were doing on the other side. 3/2 is not one of our perfect things, but we could draw a picture for it, okay? So if we draw a picture for it, tangent is positive in quadrant 1, tangent is opposite over adjacent, and then we could do the Pythagorean theorem to find that hypotenuse. So 2 squared plus 3 squared would end up being the square root of 13. Okay, so this is the triangle for theta. So remember back to our original problem, we replaced this middle part with theta. So really our problem says sine of theta now. And if we look at our picture, this is a triangle for theta. So we can take the sine of that. So the sine is 3 over root 13. And if we rationalize, we get 3 root 13 over 13. Okay, so when you have like a nested function, one function inside the other, draw a picture for what this is, and then take the sine or whatever of that picture. Okay, so here we're going to draw a picture with the cosine being -5 over 13, and then we'll take the tangent of that picture. Okay, so we'll make this equal our theta. So theta equals cosine inverse of -5 over 13. Okay, so cosine is negative, restricted in quadrant 2, adjacent over hypotenuse. If you remember your Pythagorean triples, opposite is 12. So now we're trying to find the tangent of that theta, that triangle we drew. So the tangent of that picture is -12 over 5. And that's it. Okay, so let's take a look at the bottom one. This one's just a little bit more complicated. We have some inverse functions in here. Okay, so this part is involving what we just did up top, but now it's saying cosine of this one and this one together. Okay, so if we're cosine of something plus something, we're going to use our identity. So this is like our A, and this is our B. So remember our formula for cosine of A plus B is cosine A cosine B minus sine A sine B. So just like we did in chapter 5 for the sum and difference identities, we're going to draw a picture for each of our angles and then just plug in our values. So a lot of the times when we did these before, it was like S and T. So it's the same idea here, except it's inverse. So you could say A equals arctan of root 3, and then move it over and draw your triangle just like what we did at the top. So I'm going to draw my triangle for A. So the tangent of A equals root 3, which is coming from right here. So tangent's positive, restricted in quadrant 1. So we get root 3, 1, and 2. So this is for A. And now for B, if we move the sign over, we'd have sine of B equals 1/3. So sine's positive in quadrant 3, 1, quadrant 1. If we do the Pythagorean theorem, 9 minus 1 is 8, so it would be the square root of 8, which is 2 root 2. If you don't know where I got that from, do the Pythagorean theorem and you'll get it. Okay, so now we just have to plug in. So remember, A picture, B picture. So the cosine of A, adjacent over hypotenuse, cosine of B, adjacent over hypotenuse, 2 root 2 over 3 minus sine of A is root 3 over 2, sine of B is 1/3. So we get 2 root 2 over 6 minus root 3 over 6. So 2 root 2 minus root 3 over 6. And that's it. So again, it's just like doing sum and differences from chapter 5, except they're going to give you inverse functions to start with, okay? Instead of saying like tangent of whatever, tangent of S equals root 3. They did it where you had to do that part working backwards, okay? So that is it for 6.1. Werner out.